when I take a hydrocarbon, or a carbohydrate for that matter, and I react it with oxygen gas, I'm going to produce carbon dioxide and water. Combustion reactions release a ton of heat. That's why they are exothermic. And if you got in a car to come to school today, combustion is how you got here. So here we've got something called octane, which you've probably heard about. Octane is in gasoline. Oct means there are 8 carbons in the chemical formula. And this is an example of a combustion reaction. So here it's reacting with oxygen gas, and you're forming your carbon dioxide and water. Okay? Generally speaking, when you guys approach a combustion reaction, if you have to balance it, you want to balance the O2 last. It makes it a lot easier on you. Okay? Another example of a combustion reaction, which you're probably relatively familiar with because you talked about it in biology, would be slow combustion or oxidation that happens in your body to produce energy. So here we've actually got glucose reacting with oxygen to produce carbon dioxide and water. Glucose is a carbohydrate, okay, because it's made of carbon, hydrogen, and oxygen, okay? Let's take a look at the next page. Let's go to the practice problems. Okay. What we're going to do first is we're going to classify these different types of chemical reactions, and then we're going to predict the products. So when you take a look at number 1, can you tell me what type of chemical reaction this would be? Decomposition. Because I only have one reactant. And then when it decomposes, what 2 elements would I produce?
Iron and oxygen.
Iron and oxygen. And we don't really need to know what the charge is on the iron because we're producing iron metal. Okay? And then oxygen is diatomic, so I write O2. And here, is this balanced?
No.
No. Okay, so how should I balance the oxygen? Let's start with that. 2 here. And what here? 3. Okay, and then what should I put in front of the Fe? 4. There you go. Done. Okay. What kind of reaction is number 2?
Combustion.
Yeah. Okay. What are the 2 products of a combustion reaction? Okay, carbon dioxide and water. Okay, this is not balanced. So let's start. Let's see if I put a 3 there and a 4 there. That's 6, 10. That's not going to work. This is what I suggest we do. See how I have an odd number of oxygen right here? That's going to create a problem later on, probably. So what I'm going to do is I'm going to put a 2 here to make it even. And that should help me with balancing, so I don't have to go back and erase and change everything later. How many carbons are here?
6.
So I'm going to put a 6 here on the CO2. Okay, let's look at how many hydrogens we have on the left. 2 times 7 is 14. And then don't I have another 2 here? So 14 plus 2 is 16. So we would put an 8 here. And then how many oxygens do I have on the right total? How many do I have here?
20.
12 plus 8 is 20. So what should I put here? And then I add the 2 oxygens that I have here to give me 20. 9. Okay. We're going to skip number 3 because I will never give you something like that. And number 4, decomposition, yes. Highly likely that I will never give you something like I may ask you to classify number 4 just based upon the reactant, but this is going to decompose into a metal oxide and water, I believe. You wouldn't know what metal oxide to write, so that's why I wouldn't give it to you, okay? Okay, can I go on to single replacement? Okay. Let's talk about single replacement reactions, of which there are a few different types. So this is going to involve an element with a compound. And there are 3 versions. So let me go over the 3 different types. And you may want, well, you can figure out whether you want to highlight stuff or not. The first type of single replacement reaction is generally referred to as a metal replacement. So the element that is alone on the reactant side, if it is a metal, it will replace the metal in the compound if it's more active than it. And I'll teach you how to predict that in a second. So I'm going to highlight the copper because the copper is another metal. So metals will replace metals, okay? And when that happens, strongly suggest writing this out in words. So you would write this out as potassium plus, this is copper 2 nitrate. And I'm just showing you how to do this now so you understand. The potassium and the copper 2 will switch places, okay? So you will end up with copper. And when you kick a metal out, you're kicking it out so it's just a standalone metal. It won't have a charge with it. And then we form potassium nitrate. And then you want to convert those names into chemical formulas, okay? For the next example, we have something called hydrogen replacement. This may pertain, there's a couple of different instances when you'll see something like this, but generally speaking, when you've got the element that's alone, this element that's alone, this has to be an active metal, which I will show you what those are in a second. Active metals will react with water at room temperature. Okay, what happens is it will replace the hydrogen in the water. So you want to think of water as hydrogen hydroxide. Okay, and when that happens, the sodium and the hydrogen switch, and you form sodium hydroxide and hydrogen gas. So you will see bubbles when something like this happens, okay? Then we've got something called non-metal replacement. For non-metal replacement, the element that is alone, this will typically be a halogen, which is a non-metal, which is in group 17. Okay, and that will replace the other halogen that's in the chemical formula. But it has to be, the halogen that's alone has to be more active than the halogen that's in the chemical formula in order for that to happen. So you would switch the words, you would get sodium bromide, and you would kick out iodine. Yeah.
Does non-metal replacement also apply for metalloids?
I don't think you're going to know because you're not going to get, these are going to be halogens. You're not going to get a metalloid. Highly unlikely. Yeah. Okay, now, if you take a look at the next page in your book, do you see where it says table 4.2.2 at the top? I will give you that table, you never memorize it. Okay? You use that table to predict whether these reactions will occur or not. What that means is the metal would have to be higher on the list than the metal in the chemical formula. So if you look at this example, is potassium higher on that table than copper?
Yes.
That means this reaction will happen. You can predict the products and balance it. Okay? In the next one, look at sodium. The active metals in that table are only the top 4 metals. And they tell you that, I believe, down in the sort of like the footer of the table. So you may want to make a note that lithium, potassium, calcium, and sodium. These are your active metals. They are the only ones that will replace hydrogen in water at room temperature and actually react. So if you throw another metal in with water, like if you throw lead in with water, lead is not an active metal. This would not occur. So you would just write no reaction. You would not even predict the products. You wouldn't even do it. Okay. For the non-metal replacement, you're looking at the right side of the table for this one. Okay. Because that's where the halogens are. And is bromine higher on the list than iodine?
Yes.
Okay. So that means this reaction will happen. Okay. Okay. Can I go on? Okay, I think that's it for that page. And we probably should practice this. This is, it's a lot of work. Okay, do you want me to do one and then you guys can do a few? All right, so let's take a look at number 1. I've got sodium. Sodium is a metal. Which element would it replace in the chemical formula here? Aluminum, because aluminum is also a metal. So we need to look at the activity series and see if sodium is higher on the list than aluminum. Is it?
Yes.
Yes. So this reaction will occur. So I'm just going to make a note that Na is more active than aluminum. So we know that this happens. Before I even write chemical formulas for the products, I'm writing this out in words. Sodium plus aluminum chloride. And then the sodium and the aluminum will switch places. And then I'll produce aluminum and sodium chloride. The symbol for aluminum is Al. Sodium has a +1 charge, chlorine has a -1 charge, so the chemical formula is NaCl. This is not balanced. I need 3 chlorines on the product side, so I put a 3 here. And then I have 3 sodiums, so that goes here. And then I'm done, so it's 3, 1, 1, 3. Okay, that's what you're going to do. Okay, so number 2, you probably found that the copper was below the K, so that therefore this reaction wouldn't happen, and typically it would be deemed proper to write no reaction on there. Okay. Number 3, fluorine is a halogen. Fluorine is higher than iodine on the list. Therefore, fluorine and iodine will switch places. Iodine is diatomic. That's why you write it as I2, and then you form lithium fluoride. The order in which you write lithium fluoride matters. Remember, it goes cation and then anion. If you wrote fluorine, lithium, or fluoride, lithium, or something like that, it would be deemed wrong. Okay. For number 4, calcium is one of the metals that are at the top, the 4 metals that will react with water at room temperature. So calcium will trade with the hydrogen, and that's how you form hydrogen gas, which is diatomic, and then calcium hydroxide, which is a base. Okay. Now, on that activity series, you may want to make a note of the hydrogen. Can I move this up? Can I go to the top here? So the hydrogen on this activity series is in capital letters because if you put a metal into an acid, the metal should be above the hydrogen. So this is for acids. Okay, so the metals that are above the hydrogen, they will replace the hydrogen in the acid during single replacement reactions. Does that make sense? Okay, so if you put something like zinc in sulfuric acid, zinc is higher than hydrogen. Therefore, zinc and hydrogen will trade places, and you would form zinc sulfate, and you would kick out hydrogen gas. Okay? All right, let's go to the last page, which is double replacement reactions.